Welcome to the video on the factor theorem for polynomials. In this video we use the remainder theorem we learned in the last video to find a factor of a polynomial. Then we divide into that polynomial to get its other factors. This is going to make finding the zero of our polynomials and sketching their functions much easier. It's called the factor theorem. How can we tell if a binomial like x plus 3 is going to be a factor of a polynomial without having to do the division? Well, when the remainder of a division is 0, the divisor has to be a factor of that polynomial. Take for example the number 3. It's a factor of 18 because 18 is 3 times 6 with no remainder. Just like x plus 3 is a factor of x squared plus 4x plus 3 because we can write that polynomial as a product of x plus 3 and x plus 1 with no remainder. So what we need to do is use the remainder theorem to find factors through guessing and checking. The factor theorem states, for a polynomial p of x, if p of a equals 0, then x minus a has to be a factor of p of x. This means that if you were to substitute, say, 2 into p of x and get 0, x minus 2 would be a factor of the polynomial. Or if you substituted p of minus 3 in and got 0, then x minus 3 would be a factor. We would write this as x plus 3, by the way. The converse is also true. If we were to find that x minus a is a factor of p of x, then p of a would have to equal 0, which means no remainder. The first factor is usually found by guess and check. Usually we substitute in p of 1 or p of minus 1, p of 2, p of minus 2 until we get a remainder of 0. So if we did p of 1 and got an answer of 0, then x minus 1 would be a factor. Also, if p of minus 1 equaled 0, then x plus 1 would also be a factor. Once we work out the first factor, to get another one, we usually use our division skills to find the quotient, which should then be able to find, should be able to factorize to find subsequent factors. Or we could just keep using the factor theorem and substituting into p of x until we get all the factors. Use either method that you need and which one you think will be quickest for you at the time. Let's try example 8 to see what I'm talking about. P of x is x cubed minus x squared minus 14x plus 24. We're asked to find 1, 0 of the polynomial, then express p of x as a product of linear factors. The term find 1, 0 means find a value of x which gives a remainder of 0. To do this, we substitute in p of 1 or p of minus 1 and so on until we find a remainder of 0. They want us to write it as a product of linear factors. This means that our final solution is x plus 1 times x squared minus 9. Now the first term in this example is linear because the highest power is 1. But the x squared minus 9 is a quadratic, so we have to factorize this to find the other linear factors. In this case, the solution would be x plus 1 times x plus 3 times x minus 3. Thank you, difference of two squares. So let's try subbing into our polynomial. I start with p of 1 and I get an answer of 10. This means that x minus 1 is not a factor. I then try p of minus 1 and that gives me 36. Again, not a factor. I'm going to keep doing this until I get an answer of 0. So next I try p of 2. This does give me a remainder of 0. This means that x minus 2 is a factor. Now that I've found 1, 0, I'm going to divide into my polynomial to find the others. Let's see how that's done. I know that x minus 2 is a factor, so I set up my algorithm. If you haven't watched the previous 2 videos, I encourage you to do so as it explains the next steps in quite detail. So I start by asking myself how many times x goes into x cubed, and that's x squared and that goes above the x squared term. I then multiply x squared by x and get x cubed, and then x squared times minus 2 gives me minus 2x squared. Now I subtract. The x cubes cancel each other out, and minus x squared minus 2x squared gives me positive x squared. I now bring down the minus 14x and repeat the process. X into x squared goes x times. Now I multiply. X times x gives me x squared, and x times minus 2 gives me minus 2x. I subtract. Minus 14x take away minus 2x gives me minus 12x, and I bring down the plus 24. I now repeat my process one more time. X into minus 12x goes minus 12 times. Minus 12 times x is minus 12x, and minus 12 times minus 2 gives me plus 24. If I now subtract, that gives me an answer of 0. This means that p of x can be written as x minus 2 times my quotient x squared plus x minus 12. But this second quotient is not a linear factor. I'll have to factorize that, so I can write it as x minus 2 times x plus 4 times x minus 3. Let's try another example. We are asked to find the linear factors of x to the power of 4 plus x cubed minus 7x squared minus x plus 6. The fact that this polynomial is of degree 4 means that when we find a factor and divide by it, we will be given a quotient that is 1 degree less. This means that our quotient will be of degree 3. Having a cubic to factorize is quite hard, so I'm going to find a couple of factors first and see if that helps. I start with p of 1. This gives me a remainder of 0. This means that x minus 1 is a factor. P of minus 1 also gives a remainder of 0, so x plus 1 is also a factor. Because x plus 1 and x minus 1 are both factors, this means x squared minus 1 is also a factor, because difference of two squares. So I'm going to take my polynomial and I'm going to divide it by x squared minus 1. I start by setting up my algorithm. I ask myself, how many times is x squared going to x to the power of 4? That's x squared, and I write it above my x squared term. Now I multiply x squared by x squared and I get x to the power of 4, and x squared times minus 1 gives me minus x squared. I put in a 0x cubed as a placeholder so I don't forget later on to subtract. Now it's time to subtract. The x to the power of 4's go away. X cubed minus 0x cubed is x cubed, and minus 7x squared minus x squared is minus 6x squared. I bring down the minus x, and continue with my process. X squared into x cubed goes x times x squared gives me x cubed, and x times minus 1 gives me minus x. Again, I put in 0x squared as a place value holder. I now subtract. The x squareds give me minus 6x squared, and the x's give me a value of 0. I bring down the plus 6 and repeat my process for the last time. X squared into minus 6x squared goes minus 6 times. I now multiply by minus 6, and that gives me minus 6x squared, and minus 6 times minus 1 gives me plus 6. I'm going to put the 0 in just because for consistency's sake, but you don't need to. Because now when I subtract, I notice that it's exactly the same in the top line as it is in the bottom line, and that's going to give me a remainder of 0. So I can write my polynomial p of x as x squared minus 1 times x squared plus x minus 6. But these are not linear factors, so I need to factorize these in order to get my real answer, which is x plus 1 times x minus 1 times x plus 3 times x minus 2. And that's it. The next video will be on polynomial functions, how to graph them, and pick up on the important points of these graphs. Thanks for watching.